So let's get started. Okay, so just to revise, we 1 second. Yeah. Okay, good morning. So let us get started. So let's revise what we did yesterday in yesterday's class. So we understood loops. So uh, basic structure is there is a starting point, there is an ending point, and then there is a condition to jump to next element, which is like called as increment uh, in the loops. So increment or movement of that particular variable, and then starting point and ending point. So that is something which you need to remember. And then every data type in um, Python, which can be traversed or which can be iterated, has inbuilt iterator. So I showed you yesterday on command line using the dir function. There is a double underscore iter function. So that helps us to iter. So that is something which you just need to remember, but you don't have to work on that. Okay. So okay. And then we also looked at mixed data types. Mixed data types are nothing but you can create list of sets, list of dictionaries. Within dictionary, you can have list and then so on. You can have any number of levels. So it's called as mixed data types, and the if you have levels, you can think of it as a nested data types as well. So loops which has multiple for loops, right? So those are called as nested for loops. So you can have as many for loops as you want, uh, one within another. So we will just look at where we left, which is we generated a JSON file, and we're trying to understand what is that, how do we read that file, okay? And this introduces us to a concept called as file operations. So, okay. So let us start here. So we generated this JSON yesterday, and then you can look at this. And if you imagine, so your mental picture while coding or while designing should be like this. So this is students. This is like root students, student. Okay. And then there are like 3 students here: Alice, Bob, and Charlie. And Alice has age, like probably this is age, I'm guessing it, 25. And then there is one more value, probably it's a section or something like that. And then there is the subject, which is computer science. Okay. So similarly, this also has. So this structure, if you imagine, it's like a tree, right? So you can represent trees using nested data types, which is a dictionary inside a dictionary, and then so on. You can uh, you know um, uh, you can create um, as many levels you want. Okay, so yeah. So this should be your mental picture, and this helps us to like loop through it. Okay, so how do we loop through? I'll just show you. So I'll try to save it. Okay. So you don't have to, as I was telling. So previous in previous boot camps. So I used to teach this like for about an hour about like how do you parse it. So, but since we have chatbot and which is our copilot, and you can use this because the coming generation or from like past couple of weeks, like uh, next generation won't be using any of the you won't be using your keyboard, and you won't type yourself, or probably you'll type very little. So how to use this copilot is what you have to learn. So if you choose this file, it automatically gets that file here, and then you can ask the copilot saying, I want to parse this JSON and print contents. So let us see what it does, and let us try to understand what it means. And let us create a new file, parse json.py. In fact, there is a mode called as agent mode here. So in fact, agent mode can create files and modify files all by itself. Okay, I'll show you next week how to use agent mode, and how to get control in your the software that you are creating. So the thing about agent is that it starts doing very good job, but if you don't understand what it is doing, you'll be lost. So that is why we are learning the basics, and so that you know what to ask and also how to ask. We will learn that in prompt engineering, and then how to get the desired output. So once you have that sort of a control, it's like having a, say, vacuum cleaner, which can clean very fast and very neat. But if you do not know how to use the remote control or how to control it, it will create a mess, and you won't be able to undo the things which is already done, because you cannot understand, right? So you need to have a control. So that is the main takeaway from this usage of copilots. Okay, so let us just copy paste this. So I will say put this here. So you can see here in line number 1, it has generated a code called as import JSON. So what does this mean is in one of the classes we saw C program. So in the line number 1, we have stdio.h. So we included something. So which I was giving an example, like there is a reference in the book, and then you purchase this reference book. So, and you look up that reference book for some references, right? So similarly, when you import something, we bring the functionalities from that particular module, and then we start using the functionalities of those modules. So that is what is a module called as. So in Python, a simple file, the .py file is called as module. And yeah, this is how you import a module. So also there are different ways of importing. We will come to that. But for now, just remember that importing is nothing but to bring that module into your current context and start using the functions. For example, there is a function called as load here, and then we are able to put that into your put it to use. So if you do not have access to internet, and how do you find out, right? So let me just show it here. Imports. Okay. Oh, yeah. Import JSON. Okay. And this particular library is called is a inbuilt library. So there are so you can build your own libraries and publish to common place, and then people can use it. So which means that people who have developed, there are like several libraries, and then you can actually download those libraries and start using it. So what Python guys or the Python Foundation have done is they look at the libraries which are commonly used and best implementations of those libraries, and some of them they themselves have implemented, and they have made it part of the Python installation package itself. So those are called as inbuilt libraries. So one of the libraries which is inbuilt is JSON, because we did not download anything, right? So I'll tell you how to download as well in coming. So now getting back to how to find functions which are supported in a particular given library. Okay, one thing is when you download, of course, you have internet, or if you do not have internet, um, this is how you find the functions. Okay, so just do the dir of that particular library, and it gives you list of functions, right? So yeah, for now, ignore double underscore functions and look at this scanner loads, load as encoder, dumps, dump, and so on. So you see that this particular function in line number 5, load, is present here. So if I use, say, JSON, I may imagine some function like load file, something like this. And if I start using it, let's see what happens. So it tells that JSON has no attribute called as load file. Or if I do it as a function, it will say that, so they say the same thing, like this module JSON does not have any attribute. So this particular thing that it is spitting out, right? So this is called as an exception. So exception is something which is an error, and that error is displayed or formatted in a way that you can um, understand it. So this is an attribute error because an object has two things, right? So yesterday we were just talking about objects. So it has an attribute and it has a function. So yesterday I was giving an example of book. So book has a lot of attributes where it has a color, it has size, number of pages, and things like that. And the functionality that you can operate on the top of that book is like open the book and like flip the pages and things like that, right? So those are the functions. So this is what it means. Attribute error means that attribute is not present. It's like accessing, say, staring in book. So book dot staring, but staring does not exist in the book, right? So that is an unsupported operation or unsupported attribute. So this that is what this means. And I'll tell you later when in the error handling class why it is in this format, what does these two lines mean, and so on. So that is how you import it. So once you import it, all the functions are available here, and then you can use it. So now getting back to how do we read a file is like this. So you don't understand this line, for example. So just go here and just you have selected that, and you can see it in the Copilot chat box, and you can ask it to explain this code, or simply explain. Okay, so it will go to, and it will go to like LLM models and then fetch these things. Okay, so these two lines, if you look at it, says that open the file and with this statement and all these things. Okay, so now let me explain what a file reading means in terms of the concepts, right? So let me pick up a head. So let us focus on this part. What does open mean, and what happens internally when you do the open, when you call this function? So typically any file so that we have written, or generated here, all these are stored in hard disk, right? So hard disk, and then there are like files. So each of these files are split into multiple parts because, say, for example, imagine uh, the the notebook that you have is probably on hard disk, and you want to take notes. So since we are used to writing notes in a fashion that every subject has different notebooks, and then you keep writing it in a way that you are appending the lines. So you start writing from the first page and then you flip the pages. So that is how we write. So what happens, how the computer writes, right? So how it writes is, it takes the book, uh, it looks at what is incoming data, which is something that you have typed or something you have downloaded or not downloaded, something you have in the RAM. So whatever you're working, until you press Control S, it is not saved, right? So whatever you're typing, it is still in the RAM, so which is a temporary memory, or it if you switch off the computer, like the power goes off, so you won't be able to get the data. Yeah, so that used to happen. Now there is an autosave page feature which keeps saving the file automatically, so that is why you don't see that happening. But generally, if you open any text pad and you keep writing, and then there is a power cut or you switch off the your battery runs out, you won't be able to get that data. That is because you have written something into RAM, and then before pressing the Control S, so in VA editor it is W to write, or W command, but generally it's Control plus S, and or else you go to file and then you find out that, right, yeah, save that file. So when you do that operation, it starts writing here. So it won't be in a sequential format that as we write in the book. That is because um, the amount of the data that is coming in. One thing is you won't know the size when you do the Control S. Other thing is you'll also delete some files from the hard disk, right? So some files you read or write it and then you delete it. So imagine if this is a page in your book. So if you have to write sequentially, we'll write sequentially. But imagine that you are able to delete some of the things which you have written. So you have written, say, some content here, content A and content B and content C and so on, and then you delete this part, right? And then this, since you have deleted this part or erased this part is empty. So when you take notes for the next time, so you want to make sure that you also, if there is no enough space here, which is like end of the book, you want to make use of this space as well. So that is the reason hard disk is not sequential writing. That means it is possible that your file is split into chunks and then kept it in a different places of a hard disk on the hardware. But when you see the file, all of the chunks gets combined into one big chunk, and then it is shown on the monitor, or it is shown it is read in a sequential fashion. So who does that part is operating system. Okay, so it keeps the it does the bookkeeping of which file has how it is split and things like that. Okay, so that is the reason there is a function which loads the file. So when you call this function, it invokes the operating system's open function, and then there is a read function within that, and then it does something. Okay, don't worry about that. But so that is how you need to imagine. When you double click on the file, so you are loading from the hard disk and you're bringing it into the editor or wherever. So if you have seen olden days computer, which is like there was a CPU box and all, right? So when you open any file, if you double click, say a movie file or anything like that, so it would make sound, so like a rotating sound. So that rotating sound is nothing but hard disk is rotating, and operating system is trying to pick those files, and then it is loading to RAM. From the RAM it goes to like CPU tells the monitor to like yeah, display these bits, and that bits are like combined into a movie and so on. Okay, so that is how a file works on your computer. So that is why you have load. So when you load the file, so what happens is, let me clear this drawing. When you load the file, so any given file, right, it has like beginning part of that file, and it also has ending part of that file. Okay, in this. So this is end and this is beginning. So this first character. Okay, so just like our books. So when you do the load, so internally we create, just like in for loop, we create a pointer to that particular space of the hard disk, which we are reading, and we are seeking next sections. For example, I want to read. It loads I, and then it loads M. So character by character, and we also tell internally that how many bytes or how many steps you want to move, right? So all these things happen in the load. So it loads all the characters here uh, in a particular file, which is like we are using this JSON, right? So it loads all this content character by character, and then it now the content is in RAM. So from hard disk to RAM, we have moved the content. So now how do we operate is like this. Now I want to read those content within that file. So I have so once you load, it's already there in RAM, which is like reading a file, and then it is stored in a variable called as data. So what will this data contain is a formatted version or a parsed version of this text. If you read this as a simple text, right, just using primitive or just using, there is a function called as open. So you can pass the function, pass the file name, uh, and this just read it as a simple file, not JSON file. Okay, so so if you do that, so all the content will be read as like character by character. So it won't know how to parse the JSON. So when you do this JSON.load, it internally, of course, calls the open, but it also has an additional capability to parse this particular structure into the tree structure that we have just understood. So this is student, and there are like student names here, and then their values, right? So it has that capability. So that is built into JSON. That is the reason while reading JSON files, we don't use a raw function open, but we use a library to open that file. So now this data will contain this tree. So this tree is nothing but, yesterday we saw mixed data types, right? Mixed data types or nested data types, okay, which has. So if you look at this, students is nothing but a dictionary, okay, dictionary. And then within this dictionary, what do we have? There is key and there is value. Each of this value is what? A list, right? Yeah, I hope you are following me. So this is a list, and within that list, what do we have? We have an integer, which is 25. We have a string, and we have one more string. Okay, so this is how the nested data type is represented in this particular variable, which we have just loaded in data. So now that we have converted a file to a data type, which is a mixed data type, now I can easily iterate through it. So that iteration is done using for loop, right? So in the for loop, so just yeah, for your reference, student, and then there is student names, and then there are like three more information, right? So each of this. So this is your like mental model of what we are trying to represent, and this is how we are reading. So in a print, if you want to print a variable, so this is one of the ways to print a variable. You can also like do like print name, which is a string, and simply comma name. Okay. And also this is one of the ways. So this particular, if you find these braces in a print statement, it means it is a variable. So there are several formats you can look at it, but this is one of the format. You can also print it like this as well. Okay. And yeah, so this is not a, don't get confused with dictionary or set. So this is format in string printing. Okay. So okay, you print the name, and where are the details? How are we getting the details? So data students. So how did it get hold of students? So you can see that we are accessing a key. Okay, there is, since we have these two braces, this student is embedded in another dictionary. So you can call it as like, super dictionary or something like that. Super dictionary. So you are trying to access, you got this super dictionary or the larger dictionary, which is data. And within that data, when you use students, you are accessing this entire base, which is a key of this super dictionary. Like, so you went into this and there is a key, and then there is like values inside that. So this part is the value of this particular key. Okay, so that is how you are trying to traverse. So I'll show you on command line so that you have clarity on this. So I'll do the same command. I hope it should work here. Just okay. So you can, so this is an interpreter view of Python. Okay. Internally it does the same thing, but just for a programmer's convenience, it has these three sign, what is this, greater than signs and all this, dots and things like that. But internally it is reading line by line. So that is why it is called as an interpreter, line by line. So let us look at this data. This is nothing but what we saw in our mental model. And then this is nothing but student.json. Okay. And then if we catch hold of first element, which is students, you can see that I only got this part. Okay. So this is a formatted view, but this is how the raw data looks like. So it has this part. And then if I want to access, say, what section or what is Alice's age, I can, this is a dictionary. How do you know this is a dictionary? Is you can still use, what is that, type function, and you can use it on this object. Okay. And then you can see that this is a type of a dictionary. So once you know that what is its type, you can use its, um, how to access and all these things, right? So you can say, students, I want Alice, and you can see that you just extracted only one student's data. How did we go? Like, you remember the mental model, right? So from that top of the head of the tree, so we went to next level or next node, and then we access this. And then if you want to access, so this is like, if you want to access like first element, so because now this is no more a dictionary, right? This, because we have gotten down to the second level or third level, I guess. Like, if you look at this type, so by looking at the output, you should be able to tell it is a list, right? Because it has square brackets. So now we have got a list. So how do we access an element in the list like this using? So the first element of the list is nothing but probably the age. So that is how we have gotten from like top to bottom of the tree. So now there is nothing because it's like if you do the type of this particular thing, now it is an integer. Okay. So yeah, that is your like last node. Okay. So that is how you catch hold of the data which is in a nested structure. So here in this line number from line number 8 to 12, we are trying to access the data in a loop uh, by using a variable. So this is a value, this is a key, this is a key and this is a value. So like when you do the items, it gives text in key and value. And using um, the structure that we discussed, we are trying to access those elements. That's all. It's quite simple. But if you do not do this, you'll forget it. So just try to do this and try to modify this, and you can, so the reason that you need to work out is like um, you will find some errors, and then you think why it is not working, and then you will work out and find out reason why it's not working, and then you remember you know things in a better way. So yeah, try to do these exercises. So yeah, that's about file handling and things like that. So there are different modes of a file, which means that from the hard disk, if you open a file which is being accessed or by another application or another person, if it's in the like Google Drive or something like that, so it will tell you that this file is being used by somebody else, or so do you want to open this in read mode, right? So file has couple of modes. So what we need to remember is there is a read mode, which is just read, and you cannot write into that in that application. So in this context, if I have opened the file as a read, I cannot write that because it's in read mode. So if you can open it in write mode, and also you can open it in append mode as well, which is like going to the end of the file and then writing something. So you'll come to know about that as you program, but just have a mental picture that on the hard disk there is file, and then there are different modes. Okay. So line number 4, if you look at this, so you can also do something like the alternative for this without with keyword. All the keywords are like highlighted here in pink color. So if you don't have with keyword, you would be doing something like uh, file is equal to open, and then it has auto suggested. Okay, so it knows the context, right? So you can just press tab and read the contents of the file. Okay, I'm accepting it. Now it knows what I'm trying to do. So and then do something. Okay, so you can also close the file like this, and close the file, and yeah. So without any uh, this width, this is how one would typically open the file, and you have to close the file as well, because if you don't close the file, so operating system has a way to open a file and then close a file, right? So if you don't close the file, what happens is it remains as an open file at the operating system level, and if you try to access it while this application is running, if you try to access it from somewhere else, it will say that okay, this is being used like that. Okay, so yeah, uh, this particular structure does file closing automatically. You can see that there is no file dot close here, and this is a variable. This variable is nothing but the pointer that we discussed, right? So when you load the file, it will give a pointer to the beginning of the file, and then you can use that pointer and then traverse through the file character by character, or however you want. You need to specify the steps to jump like to which location. That is done internally. So you open the file, you get the pointer, and then there is a function which will read all the content, and you know um, it will just we can do the operations here, and then we will close the file. So this is called as context managers. Why it is called as context managers is because it also takes care of releasing the resources. So releasing the resource here in this context is the file. So you are releasing the resource. So when you once you do the close, it will operating system will take care of closing the file and making sure that others, when others access, it is accessible without any problem. Okay. So that is about context managers. So yeah, you can, so when you ask it, so it will explain the similar thing. But yeah, so just understand that it is a resource manager. Okay. So it, in this one, we are just opening file, but in, say, if you're opening a database, it has its own implementation. But yeah, okay, that's about reading the file. Now let us look at what we wanted to cover. Okay, similar to JSON, there is XML file and all the files, all the content that you see on the internet, right? It is HTML content, most of it, right? So if you, so that is also structured data, because it needs to know like which part of the web page needs to go where. So that is one more structured text. So we'll try to cover Git, and I'll tell you what it is, what does it mean, and this is important because you will be working closely with Git. Okay, so so nowadays we have like from many years we have GitHub, which is a host where you can create GitHub repositories, and then you can put your code and content, and you can make others use your files. So I'll just uh, explain where did this come from and why do we do this. Okay, why do we do this source code management using Git? So this is an interesting concept. So if you write a file, so just imagine there is no Git or anything like that. So imagine that you write a file today, or like test.py, and you execute it. It is probably, say, 1000 lines. And this is your day one. And next day you come back to test.py and you modify some lines, and then it probably becomes 98 lines. So you have removed, uh, it's not like you have removed 2 lines, but you have modified a lot of things, which sums up to 98 lines. Okay. So now 2 lines are missing in terms of the total number of lines, but there could be a lot of changes. For example, you have written, uh, just for sake of convenience, A, B, C, D, and day two will be like something like a, you removed B and then you added one more line called as E and then F. So it sums up to 3, but it's not like just removing these 2, right? This this is just AD, but this is AEF. Okay. So there are changes in the constant changes in the file. So day 3 you come and then you add one more file, test.py, and then one more file is something like say test01.py, something like that. So you're adding your files, and on day 4 you realize that okay, I had written some code here on day 1, which is like line number BC. I wanted to like put it back here. So now since you have deleted on your laptop, you won't have any way to recover that. So this is how do we solve this problem, right? So this is a common problem. So this common problem is solved by something called as versioning, versions or versioning. So what I would typically do is, so if there is no software at all, so I would create a folder called as like day 1, day 2, and so on. And then every day I would take up the backup and back it up or store it back up. So on day fourth, if I want to refer this lines of code, I can simply go to day one's folder and then retrieve it or get that lines of code and put it here. So this is how I would do without any software, right? So anybody would do the same thing. Okay. So and then so this is one of the problems. So you are the only person who is working with this particular code at the moment. So imagine you collaborate with your friend and he or she wants to modify this test.py. Okay. So what you do is there is no network, there is nothing. So you give him in a pen drive, and then he takes this file and he does the same thing. Day one, day two, day three, and so on. After 2 weeks, you come here and you are also making changes here, test.py, and both of these files have their own versions. Test.py version of say person one and test.py of person two. Now there is also a common places you have modified. It's not like one person has written A, B, and other person has written D, E. It is also possible that one person has written or modified the line A and other person has modified the line A as well. Both of them are modified. Now, when you try to merge these files, you'll literally go mad because you won't know which changes to take and which is the latest. And depending on the feature you know your requirements, you will start copy pasting the lines from one place to another, and then try to make it work. So and then imagine you have like number of people are increasing in your project, and then number of files are increasing, and yeah, it's a big mess if you do not have this sort of a structured way of doing things, right? So people came up with something called as version control software. It is VCS, version control software. So what they did is just like we backed up in a folders, right? Day one, day two, day three, and so on. So they defined something called as say a commit ID. Okay, so it is okay. What this ID does is test.py, and then there is some modification. Test.py is some version. So this is version 0, just imagine. So there is version 2, and there are so many versions. And when you save the file, it sort of remembers this version. On top of this version, it makes sure that these lines, what happened to those lines. So if you have added a line, it has its own format. You don't have to worry about the format. You'll see that. So it will tell that from this line, from this version to this version, V1, you have added these lines. For example, if I have A, B, C, D lines in the beginning, version 1, and in version 2, you have modified this B into something. This is modified. So it keeps track of this. And then you have added new. So this is line is added. So how it would remember is it won't save the entire file, but it will just keep the changes in its memory. So and it will do something like this. So plus B, and then in the end you have added one more plus E and something like that. So it notes down the changes, and then it maintains this version. So it goes on like endlessly until like you discard your code, V2, V3, so on. So this versions needs to be having a unique number, right? Because if you have repeating numbers, if you want to go to change number 2, So if there are repeating numbers, there are like, you can go to any version, like, okay, this is 2, this is 2, and this is 2, and then you'll end up with the same problem. So these commit IDs are unique IDs which can tell you that what happened to that particular file on given that commit. So that is called as commit. Commit is nothing but it's like saving a file. So, but every time you save a file, v1, v2, and v3, so on, until you save the file, it's still in your like local say currently it's in RAM, just like save. And once you save, what happens is the software which is handling the code, which is the action is commit, which is like saving, but it has additional functionalities. And then it writes to its metadata. Metadata is nothing but like, it's like a bookkeeping. It will write what changed here. Okay. And then this helps us. So if you go to that particular commit ID, it will show the list of the changes. So that is how we arrived from like modifying your files to versioning. So this is any software which does this is called as version control systems. So a little bit of history of version control systems is, I'll clear this drawing. So there used to be even so there used to be companies which used to sell this kind of products. Okay, like I remember Perforce and Rational Rose by IBM and so on. So they will do the similar thing for large code bases. And there was, since there was a revolution in open source, so there was something called as SVN. I forgot the full form, but there was called something called as SVN, and then source version numbering. I don't know what is that, or something like that. Okay, so that was the first one of the first popular open source version control system, where you could commit the code, you can keep the versions and things like that. So in a running product, which is a production uh, product, for example, say Zoom. Zoom is one of products, right? So let us try to understand how Zoom team works, any given development team. So if you want to develop this product, so first thing is that you have a code here, and then you deploy it to somewhere, right? Where it is deployed in somewhere, some servers, which probably is a cloud deployment or something like that. So after you deploy, it goes to some server, right? And from there, through the internet, we are using it. Internet, and we are the users, right? So the process of writing the code and deploying the code, right? So this is in terms of uh, you know um, in terms of like corporate language, it is called as yeah, production deployment or deployment. So this is just copying the code to server and then making it work. Okay. So, and then while this code is deployed, there are also people who are working on features and fixing the bugs, right? So this code which they are working is not as the same version that is deployed in this particular computer, right? So there, there is a way to have different versions of that particular code. It's not a single file, but you can have multiple files and things like that. You have a different branch altogether, which is not a production code. So let us call this as production code. And then there is some other code, non-production code, where developers are still working and um, fixing the bugs and things like that. So once you fix this particular code here, you can copy that code, or this process is called as merging. Merge that code into production code. And in the next version, you'll get all the bugs fixed and this process continues. So there is uh, another branching and so on. So this activity of taking out or copying entire code base into a new set of branch and where people can work seamlessly is called as branching. So this is one of the reasons why we do the branching. So there could be like hundreds of branches. That is because you have single code base in during the production, but while writing the code, for example, in Zoom, you see a lot of features, right? For example, share screen and login is one of the functions, and say automatic note taking, auto notes, something like this. Okay, so these are like, if these are features, there are teams working in this. For example, if there is a team called as like which works on login, maybe it is called as authentication team or something like that. So they will have their own code base, probably a different repository. So repository is nothing but you have your own separate code which is not lying or which is not mixed with the other parts of the code. So these guys might have a totally different repository, a repo, say, let us call it as auth repo, and another team can have, say, feature repo, or features repo, which is nothing but, say, share screen repository, something like that. Okay, and each of these repositories are during your deployment, they get merged as probably microservices or some different servers or whatever. It depends on the deployment strategy, and then it becomes a final product. Okay, so this brings us to concepts called as initialization of a repository, which is like you create a repository, and within that repository, it can do a lot of operations. So you can branch out a code, which is called as branching. And of course, you need to merge that branch to some place to put it. So there is a main branch. So this used to be called as master branch, and both of them are same. So because of master is a word which is not politically correct. That is because the master comes from master and slave comes from a slavery context. So people have stopped using this word, and now people have are calling it as main branch. So initially we used to call it as, okay, this is a master branch, and the other branches are like, those are like branched out branches. Okay, so this is, if you have a mental model, I'll just erase all this. If you have a mental model, and then if you want to represent it, it will be something like this. This is your master branch, and there are several other branches branched out at some point of time. Say, let us call this as feature branch. Let us call another branch as, say, probably it is checked out here, bug fix branch, bug fixes. That is the reason you see versions of the software, right? So if you download any software, it will keep updating, right, on your Android phone and wherever you're using software. So Zoom might be having something like Zoom 7.8 dot some one version. Probably this is called as major version, minor version, and bug fixes, and probably it has its own nomenclature, but don't worry about it. So where all this are coming is from these branches. So you have your initial code here, which is to initial repository, like you design the software. For example, if we want to start our code from from the point where we have started, I would initialize a repository with JSON parsing file, and then I would check that in, or I would commit that code, and others can use. So this is how the mental model of a source code or version control system. Okay. So coming to Git, so now you understand the general concepts of um, like what is branching, why it is done, and merging, and so on. So feature branch could be merged somewhere here and released, and it still goes on. And your bug fixes may come here. So, for example, this happened in January. This happened in this is a timeline. So this could be in March. This could be in March like 30 or something like that. So you can have multiple. So using this main branch is where your final product is. So that is why it's called as main branch. Okay. So I'll show you the Git repository and branches and so on from random repositories. So coming to Git, so Git um, is a tool, version control tool, which was developed by the same guy who developed Linux. So his name is Linus Torvalds. He's a Finnish guy. So uh, what he did was, so he found he wrote this for himself. So he was writing the kernel code of Linux, right? So there were like several people who were working with him. So he found SVN, which was like a previous software, SVN, and he found that this is not like scalable to, and this does not have some features. So he started writing his own code, and then it became. And by the way, he wrote it in just 10 days, and then Git became famous. And after it became famous, one of the guys, I think his name is Thomas, um, a German guy. So he built a company around Git. So he took it to like internet. And Git was initially like you could install Git here, and over the network you could share in a company, or you could share that a particular code, and people would work on that. So somebody who took this and made it a product or service, that is what we today we know it as GitHub. So GitHub became famous, and then somebody like this guy, I think Bill Gates or uh, Satya Nadella, he looked at the potential of GitHub because it has all the, like, so many people are writing code and checking in the code. He looked at the potential and they bought this company. Now Git is part of your Microsoft uh, company, and then now these guys are building like a lot of tools. Right, VS Code is your Microsoft tool. Now you can integrate GitHub into your VS Code and things like that. So these are the like uh, you know events that are happening in this world, and that is why we use Git. So in GitHub, so you might have created an account. You can also create a repository and then download that repository into your local folder, and then from there you can start working. Okay, so we will I'll show you the repository for now, and then we will actually go to use it, use one repository, and everybody can create their own branch and start using it, right? So I'll create that repository, and then you can use it. So let us go to browser, and yeah, this is my account. And if you go to any account, if you have created branches, it will like give the list, right? And let me take some branch, okay, some repository. So let us take a random repository. Let me take Celery. Celery is one of the tools. So this is a random repository. This is a like popular tool for making queues, like distributed queues. Okay. So if you look at this, this is their like code. Okay. And their team, you can also like look at go to their settings and look at who are the developers in that, which is a team. And you can look at this particular this one. There are like 54 branches. And as I was explaining, there is also a main branch, right? So this is the main branch. So if you look at this, these are the like branches. If you go to branches, you get list of all the branches. So this particular main branch um, is your production code, where if you download Celery, like pip install, or there is a way to install, but if you download, this is the branch you're going to download it. And a lot of people are using different branches, and they're like checking in the code. You can see there are like statistics and tools built around it to make sure that the test cases are in place because when you check in the code or the commit the code from this branch to main branch, right? What happens is it's possible that you have put in a lot of bugs, or you have put in features which are like not approved or anything like that, because anybody can check out. So I can go here and I can simply say um, there is also something called as pull request. We'll understand what is pull request. Pull request is nothing but I have modified the code and I'm pushing that into the main repository or some other branch. So that particular thing, you cannot simply merge it. There is a person who needs to approve it, right? So why there should be a person? Because somebody should be watching that repository who is like a say repository owner, or if you forget the management, so you can think of them as product owners. So they need to approve that. So that is called as pull request. We'll look at that. And you can also like raise issues and things like that. So that is about branches. You can also see commits. So you can look at these commits. These commits are nothing but within the main branch. So if you go to any commit, so let me go to say this commit, remove. Okay. You can see that there is a commit message, and you can also see that what file has got changed. So this is a previous version, and this is a current version. So it gives in a diff. So minus means which is like this part was taken off, right? And yeah, things like that. So now I hope you understood the concept. You have got a mental model of what we try to understand, and then you have a picture, or when you have a live model to connect those dots. So this is what a version control software means. So now they have done it as a service. GitHub guys have done it as a service, but without all this, you can simply install Git on your laptop and do exactly the same thing. And VS Code has this particular section where you can just click and you can initialize the repository. So the current code can be as a new repository, and you can also publish to GitHub. So this is GitHub has nothing to do with Git. GitHub is a service built on this all the repositories, but you can have private repositories. You can develop the code on your laptop, and you can share the code. You can add people and so on. Okay, so that is about Git. And yeah, try to explore about Git, because we are going to in future classes we are going to write the code. You're going to take that check out that code in your own laptop, and then you modify something, and then you push that back in. So we will simulate working in a team. Like you modify something, it goes into this one, and then somebody would accept the pull requests and approve that, and it goes into main branch, and then we can use that as like end product, something like that. So okay, so yeah, that is about Git, and I wanted to cover this things this week. Next week, I'll also start with something called as prompt engineering, which is like really important because we don't write any code. So your overall goal should be like hands off the code, but your mental model should be very clear, or else you'll get lost in the process. Okay. Yeah. Thanks for attending, and yeah, have a great weekend. See you on Monday.